Hello, good evening. So, we will be continuing the previous class where we were talking about the importance of analytical chemistry on all spheres of our life, starting from all branches of engineering, the medicine, physics and all this. So, in our previous class what we are talking about that if we can have our own samples from any engineering discipline like civil, chemical, electrical and mechanical, as we are talking about the IC engine, that means the exhaust, and also the some other thing, that means the fuel or any other thing which we can consume in this internal combustion engine, that can be analyzed, because those analyses are very much important. So, if we go further in any other branch, say like medicine. So, if we have some medicine, that means if we can have the corresponding analysis in terms of the clinical chemistry, as we were talking about the sample of blood to treat some illness or your condition, that means how much hemoglobin you have, or the dissolved gases like O2 and CO2. So, clinical chemistry is a very major thing in all medicinal subjects and is nothing but what we consider as the clinical chemistry. It can be considered as the clinical biochemistry or clinical analytical chemistry related to the biological analysis, and also definitely it will be related to the main branch of medicinal chemistry. So, this medicinal chemistry, when we talk about of any sample, so any unknown sample covering this medicinal chemistry, it can be analyzed. Then pharmacy and toxicology. So, these are the branches which can be benefited from the knowledge of this analytical science. We consider as typically analytical science, when the chemical knowledge or the analytical chemistry knowledge can be very much useful to find out something which will be directly related to the toxicology. So, in a typical example, in today's class possibly we will be able to discuss something how toxicology or the determination of the toxic effect of some species to anything can be determined with the help of a simple knowledge of analytical chemistry, its methodology and some sets of ideas. So, the toxicology we will be talking today. Then if we go for another branch which is very much important to us, is the characterization of materials. So, it is materials science. So, this branch is also benefited from the knowledge of analytical science, that means the materials chemistry involving metallurgy, then analysis of polymers, characterization and any solid state material. Suppose we go for or we make something what we all know that a very useful material which is present in the solid state. So, a superconducting material, all we know that a superconducting material is very much useful and can be synthesized from typical knowledge of chemistry, solid state chemistry rather, and that can give us to something which is based on some copper oxides. So, if we want to analyze the percentage of individual metal ions present in that solid state material which can be useful for its superconducting behavior, so we have to take the knowledge of this analytical chemistry to analyze this solid state material. Then we can have its application in the field of agriculture, where we can see that there are several areas like agronomy, then animal science, such as the animal feeds we can analyze, then crop science, how the yield of crop can be increased. Then as I told you in our previous class that how food science can be benefited from a typical knowledge of analytical chemistry, where we can analyze the food material from its corresponding content of nitrogen, that means the content of corresponding protein. Then how we can analyze the corresponding soil which is utilized for production of this crop, this food and all these things. So, that is also related. So, soil, that means during that particular analysis we know that the soil, how we can use urea, a fertilizer, or the corresponding nitrogen content of the soil, that means how the ammonia content in the soil is present. So, if the fertilizer urea is added, and soil we all know has ureases also, and how much urea is there present, that can be analyzed due to that particular involvement of this analytical chemistry in soil science, and is also useful for the horticulture, the flowers and all these things, how the flowers and all these things will be chemically dependent on some material, say the quality of the soil, the quality of the fertilizer and all these things. So, those can be analyzed from a typical knowledge of this analytical chemistry. Then comes our environmental science, and as I told you that how we can analyze our environment. So, that will be dependent on the analysis related to environmental science, where we can have the ecological balance, knowing how the ecology is dependent on the corresponding presence of the different species or the different samples, which can be analyzed by using a typical analytical method. Then meteorology, suppose we want to analyze some meteor. So, meteor can be there, so that can give rise to some solid sample. So, that solid can be grounded, can be making their powder form, and that powder form can be utilized for the analysis of its corresponding elemental composition or the elements. So, this meteorology and oceanography also, where we can have some idea about the corresponding oceans, the tides in the oceans related to the corresponding contamination of the water content or the water quality of this particular ocean. Then we can use this in case of the subject which is well known to us, the geology, that we are talking about in our previous class, that how we can analyze the ore samples. So, starting from this geology, the geophysics, the geochemistry and paleontology, all will be benefited from a typical knowledge of this analytical chemistry, where we can analyze the ore sample, or we can have the minerals, or as I told you earlier that how we can analyze the gemstone also, where the corresponding content of chromium, as I told you, that in present in case of the corresponding ruby, which can be analyzed by means of this geological subject. Then lastly, that means we are just completing the whole circular thing, that means starting from our biochemical to physics and all these things, will now reaching for the corresponding analysis for biological samples. So, biology will also be benefited from the knowledge of this analytical chemistry, where we can find that the molecular biology also within this, then microbiology, then botany and genetics. So, these basically gives us some very good idea about the what are the areas we can cover, but it is not difficult to cover all these in this particular class, that we can give some typical examples. Suppose we go for something where we can have some material, that how we can understand the corresponding nature. So, if we will be talking about this particular application of analytical chemistry to understand nature. So, how to understand that? That is typical some sample. So, from the nature we should get some sample, and I will give you some typical example for that, where we know that during July in the year of 97, we were exploring, particularly this Americans sent something to analyze the Martian surface, the Mars, and its corresponding surface. So, they sent the Pathfinder spacecraft. The Pathfinder spacecraft was sent to analyze the corresponding elemental composition firstly, because we will be looking for something what are the elements present on the Mars surface, and this Mars surface what we get as the corresponding Martian rock. So, if we have the corresponding rock and definitely the derived soil also from the rock samples on the Mars. So, this spacecraft which is there, so it has a rover attached to it, and that rover is basically utilized for carrying some instruments. So, that is the very simple idea. That means, what are the methods what we can use to understand or analyze. So, if we go for the analysis of this rock and soil sample, and if we take the corresponding help of the instruments, because this particular thing, that means the Pathfinder spacecraft which is carrying the corresponding instrumental part, and if we consider this as the corresponding analytical tool, that means the instrument is our analytical tool, we can consider it as the typical instrumental methods of analysis. And since it is on the Mars surface and is a very complicated one, and some physical measurements, because we cannot have the analysis, that means the corresponding elemental analysis. Say our goal is to determine the corresponding elemental composition of the rock and the soil sample if we get it from the surface of the Mars. So, this elemental analysis can be done by using some instrumental technique, and definitely we will be using the corresponding physical methods or the physical measurements, because these instruments continuously they can collect for the several days during which the spacecraft was landed on the Mars and was staying on the Mars surface, that they were continuously collecting some amount of data, and the data is being transmitted on the Earth. So, what is that particular instrument is basically, I am giving some example, we will be talking when we talk about the instruments. So, it is basically APXS. So, what is this? So, S basically something attached with the name of S is definitely a spectrometer. So, if you are asked what has been carried to the Mars surface by this Pathfinder spacecraft is the corresponding spectrometer, and this corresponding APXS spectrometer is there, and X as is very common to us, very common to physicists, very common to chemists, is the corresponding X-ray, and P is related to something which is very fundamental to our knowledge in terms of the electron, protons and neutrons. So, it is the proton. So, all these things are known. S is spectrometer. So, it is carrying a spectrometer, and spectrometer will be utilized for analyzing the surface of the Mars and is utilizing X-ray, and some proton is also involved, and this A is nothing but the corresponding alpha, that means the alpha particle. So, the full name of this instrument is alpha proton X-ray spectrometer. What it does basically three things. So, this spectrometer is doing for three things, and we will be talking these three things, that means three types of measurements it can do. In the first case, that alpha particles. So, you have these alpha particles. So, alpha particles are there. So, these alpha particles are basically attacking the nuclei of the elements. What are those elements? That means the elements present in the rock and soil surface. So, the alpha particle plus nuclei, the interaction of this alpha particle with this nuclei of the light elements, nuclei of the light elements causing some emission of proton. So, this causes the proton emission. So, basically we get something which is known as proton emission spectroscopy. This is called proton emission spectroscopy. This is abbreviated as proton emission spectroscopy. So, when something is emitted, if we can have some detecting mechanism, the detector will be there which can analyze the corresponding emission of this proton from that particular interaction. So, these basically coupled with three advanced instrumental techniques. So, it is definitely a very complicated one. So, during our course separately we will be learning how a spectrometer or spectrophotometer can be useful for analytical chemistry or chemical analysis. If we use X-ray as the source of radiation, how X-ray can also be useful. Then something related to the nuclear chemistry, that means alpha particles are hitting and protons are emitted from there, which can give rise to a corresponding emission of proton, and that is giving the corresponding spectroscopy. So, what basically gives us from this is that this particular thing, that means the alpha particle what is emitted from there, and we can analyze this proton emission spectroscopy, because this alpha particle is coming from a source of corium, which is 244 corium, which is a source of alpha particle that can give the flow that can emit some alpha particle from this spectrometer, and which is attacking the nuclei of the light elements. Why we are doing so? Because these particular information can be helpful to us for the identification of the sodium, magnesium, aluminum, silicon and sulfur. So, if these are present, all these elements are present, because our basic idea, as I told you, is that elemental analysis with the help of an instrument, and what we are doing, we are getting the sample from a very remote source, which is nothing but the Mars. So, these are basically that means the corresponding composition, that means whether sodium is present, magnesium or sulfur, and there some amount of the percentage, and these percentages are also very less. So, the elements, so the elemental identification is possible with the use of these instrument. And what about the first one? The first one is the corresponding X-rays are used. So, these X-rays are utilized for the corresponding thing, that means it is known as the Rutherford backscattering spectroscopy. So, name may be complicated, but you just listen. It is the name of the scientist, the Rutherford backscattering spectroscopy. So, you see that all are spectroscopic things. So, analysis is through spectroscopy. So, that is a very important and the major part what we will be talking afterwards, that the spectroscopic analysis, instrumental analysis is nothing but the spectroscopic analysis. So, what basically gives us this Rutherford backscattering spectroscopy like this of your corresponding alpha proton interaction or alpha particles are interacting with the nucleus. So, this Rutherford backscattering spectroscopy is basically giving us the corresponding identification of carbon and the oxygen. So, this is a very important information what we will be gathering, that whether the surface of the Mars can have the corresponding carbon content present in it, because the carbon content present in it has some kind of direct relationship with the presence of the corresponding living thing, that means the plants, that means the animal thing or something which can give rise to the corresponding composition in terms of the presence of the carbon. So, carbon, oxygen and all other these elements can be identified by these techniques. So, this is number 1, this is number 2 and the third is basically utilizing the X-ray. So, X-ray and a particular process which is corresponding fluorescence. So, if we can X-ray fluorescence from there, and these are giving rise to corresponding elements like from sodium to up to iron in the periodic table. So, large number of these particular species which have a very characteristic fluorescence pattern that can be identified the way we talk in terms of the corresponding flame test in our school days, that the sodium we all know that giving rise to the flame, a characteristic color of this flame. Similarly, other elements also, potassium can also give rise to the flame test. Similarly, this is a particular technique, is the emission technique. X-ray is utilized for the excitation, and when the emission is taking place in terms of its fluorescence. So, that can be analyzed for all these elements. So, quantitatively, so this elemental analysis is basically giving rise to some quantitative estimation. So, this quantitative estimation is possible in terms of the corresponding percentages of carbon to say iron. So, we get something related to this particular type of analysis. So, any kind of this analysis if we can have, first thing that whether we go for a solution analysis or a solid state analysis, using that we initially get something which we consider as a corresponding qualitative information. So, qualitative information what we can get, that is also known as the corresponding qualitative analysis. So, it is required for establishing the corresponding chemical identity of the material, because whether we are getting some material as a carbon or that material as iron. So, chemical identity of that particular species which is unknown species. So, species is known to us which is present in the sample. So, if we have this particular species, so if we can have carbon based some compound or some iron or its compound, say as I told you that it can have some oxide or any other composition, that means the oxides, sulfides and all these things. So, this qualitative information what is giving us give rise to some analysis which we can term as the corresponding qualitative analysis. So, is known as qualitative chemical analysis. So, this is important because what we are talking about the Mars surface is the elements which are available on the Mars surface. So, quantitation. So, quantitation of all the elements which are present over there except hydrogen and helium, because hydrogen and helium cannot be detected through all these three different techniques, three very advanced level of these instrumental techniques, and this concentration is in the range of greater than 0.2%, which is not always very easy to do by conventional analytical technique. What we will be learning in our next classes, that a typical analysis after identification, that means after qualitative identification, we can go for the corresponding quantitative analysis. So, in case of quantitative analysis, so the other part is the corresponding quantitative estimation. That means the detection of carbon, the detection of iron, detection of sulfur, detection of the surface as it's, if it is silica is present, that means the silicon based surface is there. So, silica based surfaces can also be identified, and this particular percentage, which is greater than 0.2% only weight by weight. So, this very small percentage of all these elements which can be detected by this particular technique, and the amount is also this particular quantity. So, it basically gives rise to some relative amounts also. The relative amounts of all these species, which basically indicates us that how these each substances are present. That means, each of these substances which are present in this particular sample. So, these unknown species which is there and which we are analyze. So, these are known as analytes. So, this is a typical terminology which we will be utilizing or which we will discuss by us. We will discuss this. So, there in these analytes we try to understand that what are the components present which we can determine. So, anything which is unknown. So, any unknown sample. So, here at the top basically we can have the unknown sample, and our basic idea is that how we can analyze this particular unknown sample. So, we have to go for typical analysis. So, this analytical technique will be available such that we can determine the corresponding elemental composition if we go for elemental analysis, such as we are determining the Martian rock. So, from Martian rock basically if we can have, we are talking about the Martian rock, do not worry about all these things, that means it can be very sophisticated or a very advanced technique you can think of. But if we can have idea that how far you can go, how useful this subject is by knowing the corresponding composition of the Martian rock, its development, and its ultimately how it is giving rise to some other transformation from there to that of our terrestrial rock, that means the surface of our earth. So, anything is available from there. So, this is there, that means the typical earth surface, because still we do not know, there are several places, several mountains, several rocks and all these things, we do not know the composition of all these. So, geologists are very much engaged to understand the corresponding analysis of these rock samples. So, basically we will be utilizing initially the identification, the qualitative information, then the quantitative information to understand these. And remember that we just do not be very much involved with the sample. So, if we have the rock sample and if this rock sample is given to you as a powder form, so it is like anything, that means any unknown sample what we get and what we can analyze from our school days, in our colleges, in the laboratory classes. So, only thing that the origin is different. So, rock samples, whether it is a terrestrial rock or a Martian rock, you make it powder. So, this powder we can analyze. So, what are those things and what are the different steps and what are the methods and the procedures we can adopt to analyze this sample, which is an unknown sample and which is in the powdered form, to utilize for the corresponding analysis, whether we are utilizing some instrument or we are going for standard titrimetric or some other technique for this typical analysis. Okay. So, that we will see in our next class.